solids according to the particle model. I've drawn a diagram of a solid over here. You can see all these particles drawn in red. Notice how they're very closely packed together. That's exactly what solids are like. There's very little spaces in between because the attraction force is so strong, it's pulled these particles as close as they can be to each other. Now, because the attraction force is so strong, we get a few consequences here. The first consequence is that it maintains its shape. It won't crumble apart because it's really tightly bound. And also, now they behave like a cohesive unit or a group, and so they have a defined volume. They don't flow or anything like that. They're very tightly packed and held together. And this also means that these particles, according to the properties here, is that they're always moving. But they can't go anywhere because, again, the attraction force is so strong in this case that the only thing that they can do is so they can just vibrate in their place. So the particles you should be imagining as being little vibrating spheres. One last thing before we go is that you can't compress solids. Again, they're tight, they're bound as tight as they can be. There's no more space, there's no more slop or margin for squishing them into a smaller three-dimensional space because they're packed so tightly, so that makes them incompressible. With that said, we're going to get into our next video on the liquids.